So now let's talk about deployment. This is where it gets really interesting. What is CV actually doing for us every single day?
Oh, the list is huge and growing. We've mentioned self-driving vehicles, which are basically using CV to build a live 360-degree map of the world around them. But in manufacturing, machine inspection is a massive area.
And how does that outperform a human inspector on a factory line?
Well, it comes down to consistency and speed, really. A CV system can spot microscopic defects on, say, a circuit board or in a bottle of medicine, and it does it with perfect objectivity 244/7, something a human eye just can't maintain over an 8-hour shift.
Right. It guarantees a level of quality control that was impossible before.
It really does. And then you see it in highly specialized fields like medicine. In healthcare, CV models are helping evaluate tumors. They assist in surgical navigation. They flag suspicious spots in X-rays or MRIs way faster than a person can. They act as a really crucial second opinion for doctors.
And then there's the stuff we see every day, like on our phones.
All the time. Facial recognition for tagging photos on social media or live surveillance monitoring where CCTV feeds are analyzed to spot specific events or behaviors.
And even just the simple act of, scanning a document.
That's OCR, optical character recognition. It pulls printed or even handwritten text from things like invoices and forms and turns all that inert paper into searchable digital data. It has completely digitized the world's archives.
It all sounds incredibly powerful, but as with any technology this transformative, it's not perfect. There have to be major hurdles. When you look at the research, what are the biggest challenges CV is facing right now?
I think the sources point to a key distinction between just identifying something and truly comprehending it. So the first challenge is definitely reasoning and analytical issues.
Okay, what does that mean exactly?
It means that current models are brilliant at pattern matching. They can identify an object with incredible accuracy, but they really struggle to understand context or spatial relationships or to infer intent from a scene.
So it can see a person standing next to a shovel, but it has no idea that the person is about to dig a hole.
That is a perfect way to frame it. It lacks that common sense knowledge base we use to reason about the world. The next big challenge is more logistical, the difficulty in image acquisition.
But there's so much data out there. Why is getting the images still so hard?
Because the real world is chaotic. A perfectly trained model can fail in an instant when it sees something it wasn't trained on. Sudden harsh lighting, heavy rain blurring the camera, glare, or just objects overlapping in weird ways.
Occlusions.
Occlusions, yes. Getting enough high-quality labeled data that covers all of those weird edge cases is incredibly expensive and difficult.
And then, of course, there are the big societal questions that come with any technology that can identify and track people.
And that's the third major challenge, privacy and security concerns. Vision-powered systems, especially mass surveillance and facial recognition, are obviously very powerful tools. And that power raises very serious questions about individual privacy, data security, and the potential for misuse.
It's a classic case of the technology outpacing the regulation.
It is. We need careful frameworks to balance the security benefits against civil liberties. And finally, there's the problem of trust.
Trust in what we see.
Exactly.
Yeah.
The fourth challenge is duplicate and false content. The same technology that allows a machine to understand an image can be turned on its head and used to create incredibly convincing misinformation. Deepfakes.
Right.
These manipulated videos and images are a direct threat to everything from politics to finance. So CV systems don't just have to learn to recognize reality. They also have to learn how to spot highly realistic fakes.
We have covered so much ground in this deep dive. We've gone from the basic math of light as a grid of numbers all the way through those 5 intense processing stages and right up to these applications that are redefining entire industries.
And I think the key takeaway is that all this incredible power is fueled by two things. These huge breakthroughs in deep learning and just vast, vast amounts of labeled training data, that human-level performance they talk about. It's because these systems have seen and analyzed billions of curated images.
Which brings us to a final provocative thought for you to think about. If the power of computer vision comes entirely from these models that have been trained on curated data, if they only know what we've explicitly shown them, what are the real risks when these systems encounter something truly new, something ambiguous, or a situation so specific that it falls completely outside the boundaries of their training data?
That gap, the gap between the clean, controlled training world and the messy, unpredictable real world,
Yeah.
that is the absolute boundary where machine sight ends and human interpretation still has to take over.
Something to think about the next time an algorithm unlocks your phone or suggests a new friend to tag. Thank you for joining us on this deep dive. We'll see you next time.